Number 14, I will help you draw this graph. Then I give you 2 so that you can perfect your skill at drawing, and I'll provide the answers. Table 1 shows the profit earned by Works Enterprise for 4 years. The table has time in years 1, 2, 3, and 4, and profit in shillings 45,000, 50,000, 55,000, and 60,000. So what you do here, we are supposed to plot a graph of profit against time. So what you are supposed to do, you draw your graph in this manner. Then we have the vertical axis where we have the profit in shillings, and the horizontal axis where we have time in years. So here you write 10,000, here you write 20,000, here you write 30,000, 40,000, 50,000, 60,000, and so on and so forth. And remember, they should be uniformly spaced, like from 0 to 10,000 we have 2 larger boxes, 10,000 to 20,000 2 larger boxes, and so on and so forth, all the way to 70,000. Our highest value in the table is 60,000, so we don't really have to go beyond 70,000. Then when we come back down here in the x-axis, so time in years, our time runs from 1, 2, 3, 4, and 5. So remember, also from 0 to 1 we have 2 larger boxes, then from 1 to 2 again 2 larger boxes, and so on and so forth. So your scale has to be uniform, like from 0 to 1 it should be equal to, from 1 to 2 it should be equal, from 2 to 3, and so on and so forth. So we call that scale linear. 0 to 10,000 should be equal, from 10,000 to 20,000, and so on. So we call that scale, it is uniform or a linear scale. So now when you are plotting, I want you to check in the table here, copy these values aside, pause the video, copy the values aside, so that we can learn how to do the graph now. So now when you are plotting, for instance, our first value was 1,000, 1 against 40,000. So let's just put this one. It was 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, and so on. So it was 1 against 45,000. So if this is 40,000 and this is 50,000, then the middle between there is where I've put the red, that is 45,000. Then 2 against 50,000, just follow from 2 to 50,000. Then the next one you follow from 3 moving up to where we have 55,000, 55,000, in between 50 and 60,000. Then the last one will be 60,000 against 4. Yes, so 4 against 60,000. Then what you do, we are supposed to draw a line of best fit, a straight line that touches all of your points, or most of the points if not all, but you try as much as possible to touch at least 75% of the points. Now there are many other ways you can draw this graph, like some students would drop the break these values below, but it would give you a challenge when you are reading off values from the graph. So I picked this type or this approach to make your work easier. So this is the required graph. I just added a title as well, but not really necessary. We look at the axis labeled profit in shillings and the horizontal time in years. We look at the scale, it has to be linear, both the vertical and the horizontal. Then another thing is we look at the values on how you have plotted. You should plot your values very well. So sometimes we give you 1, sometimes 2, then the line on how uniform your line is. So I want you to pause the video, draw this table, copy this question, and I want you to draw a graph of amount against number of units. I forgot to mention in the example, if we just say amount against number without mentioning the axis, the first one should be in y-axis and the second value should be in x-axis. So I want you to try, then you also find the standing charge, then I'll be showing you the answers in a short while. And secondly, I also want you to pause this video and draw this graph. Draw the line of best fit on the graph. Remember, this is just x and y, so you plot x and y. That means y will be vertical axis and x will be horizontal axis, and again we're supposed to read off the y-intercept. So this is the first graph, amount against the number of units. So when you draw, you realize that in the horizontal axis we have 0, 10, 20, 30, 40. Again, I've just been using the two larger units to have uniform scale, so 10, 20 and so on. Then in the vertical, two larger units or 2 centimeters to represent 20 units, so trans 20, 40, 60 and so on. So when you are plotting, a line did cut here between 60 and 70. Then you can check my graph. Here it's a line of best fit. At least it has tried touching all the points. This one almost went off, but it has touched almost all the points. Now when you're supposed to read or to state the standing charge, you simply read where the line cuts the vertical or the x-axis. Your value may slightly be different because this is graph work. So for my case, it did cut between 60 and 80, which is 70. So my standing charge is 80 Kenya shillings. Okay, then the next graph is here, whereby you're supposed to now plot x against y, and x was ranging from 1 all the way to 6. So I have 0, 1, 2, 3, 4 all the way to 6. So again, you can see my scale. I've used 2 centimeters to represent 1 unit. This larger box is 1 centimeter if you measure. Then on the vertical side, 2 centimeter to represent 2 units, or 1 centimeter to represent 1. So again, you realize that if I draw, I want you to look at this one carefully. My line did not touch all the points. Look at this point. It was slightly, almost, but out. This one is now very far. So it touched exactly 1, 2, 3. This one is not very far, and this one. So you can see that it's a line of best fit because it's touching most of my points. So when you draw, remember to use a linear or uniform scale. The scale doesn't have to be the same. You can see here I've used 2, 4, 6, and this side I've said 1, 2, 3. The two scales don't have to be exactly the same, but you ensure that you cater for all your values. Then we are also supposed to read off the y-intercept. Y-intercept is exactly where your line cuts the vertical axis. So if I look at my graph very well, it's between 1 and 1.2. That's why you can see here I've said it's 1.1. I want you to try as much as possible to practice. In case you have any challenge, just reach out. I'll be able to help. You can share this video with your friends and family to also encourage and help them improve in mathematics. God bless you abundantly.